If you get more information, please let us know.
That's probably all that I will know. Alright, please make sure you picked up the handout at the door. If you forgot to grab it, please go grab it real quick, please.
Instead of starting to enforce it.
Everybody back. Here.
Who else did that leave facility during the day?
Everybody's back.
They also don't let them leave at night.
Just you wait.
Alright, so we need to move on to 10.6 and start looking at what's going to be different here. So I would say from the 10.1 through 10.5 stuff, geometric and p-series are going to be the most common for sure. This is, I don't think I was able to number this one for you, but this is supposed to be number 42. So there's really two things we're kind of looking at in here. Two tests we're adding to our list. So we've got the nth term test, where you take the limit as n goes to infinity. If it equals 0, you know nothing. If it doesn't equal 0, you know it diverges. We've got the integral test, where you can integrate it. If the integral converges, your infinite series converges. If the integral diverges, your infinite series diverges. P-series, if p is greater than 1, it converges. If p is less than 1, it diverges. All of those things, but now we're going to do a comparison test. And so there's two. First off, let me make sure that you understand there's really two different things we're going to talk about here. There's the comparison test, and then down here there's the limit comparison test. Make sure that you understand these two processes are a little bit different. So the comparison test, I think, is pretty intuitive because it says if a sub n, so a sub n is like this thing, the sequence. But if we compare it to another sequence that we're going to call b sub n, if b sub n is bigger than a sub n, and the series of b sub n converges, so think about that. Converges means it heads to a number. So pick a number. 2. Okay, let's say this converges to 2. If this converges to 2 and a sub n is less than that, it's less than 2, then he also has to converge. So visually, it's like saying if this is b sub n and it's converging to some number, it's kind of leveling out and converging to some number, and a sub n is smaller than that, then it also has to converge. Okay, but if a sub n diverges, meaning that it goes to infinity, or doesn't settle on a number, and b sub n is bigger, so it goes to a number bigger than infinity, then this one also diverges. Doesn't that make sense? If this goes to infinity and this is bigger than this, then this has to go to infinity also. If this converges and this is smaller than it, then it also has to converge. So, again, this relies on us still doing geometric and some of those other things. So, now you could do a question like number 1, figure out if this converges or diverges. And again, it's not the harmonic series, it's not a p-series, it's not a geometric series, it's none of those things. But probably the hardest part of this is you kind of have to look in here and you kind of have to see one of those that you know the answer to. So if I compare, I'm doing the comparison test, if I just look at this part of it, 1 over 2 to the n, that is geometric, where r is a half, and since the absolute value of r is less than 1, it converges or diverges?
Converges.
Okay. How that is helpful is now I'm going to compare these two things. I know this converges. If this is bigger than something that converges, then I didn't learn anything, because if it's bigger than something that converges, it could be going to infinity itself. But if it's less than something that converges, then I know this converges also. So one of these is 1 over 2 to the n. One of these is 1 over 2 to the n plus 3. Which one of these is bigger? if we make the denominator bigger, does that make a fraction bigger or smaller?
Oh
Okay.
my gosh. Yeah, I said that.
I didn't say anything. So if this guy converges and this guy is smaller than it, he also has to converge. Now again, if you can't see seeing the 1/2n to compare it to, again, is going to be the hardest part. That's even after all of this practice today, that's going to be the part that can be a struggle at times. But what do you think we should compare it to in question 2? 1/4n. Okay, and 1/4 to the n, does that converge or diverge? Converges, it's geometric. You'd be multiplying by 1/4 each time. So if 1/4 to the n converges, then the limit comparison test, not the limit comparison test, the regular comparison test is helpful if this is bigger or smaller than this. Smaller. And if it's bigger, that doesn't help me, because this converges to something. I could figure it out because it's geometric. But if I know this is bigger than something, this goes to 5 and I know this is bigger, I can't guarantee that doesn't go to infinity. I can only say if this goes to some number, converges, and this is smaller, then it also converges. So now we have to compare these to see how that helps. If I make my denominator smaller, does that make your fraction bigger or smaller? Okay, so does that mean this converges? No, that means 1/4 to the n was a bad thing to pick. Now, there's no way for you to know that off, right away, but that's what I tried on my paper as well. But now we could come back and say, well, what if I said 1/3 to the n? That's still geometric, that converges. Now, when I compare these, can you see that this will have to be smaller? Because 4 to the n is going to grow a lot faster than 3 to the n. By the way, I know this part you guys won't be crazy about either, but when you're just adding or subtracting a number like this, when you're talking about numbers that are close to infinity, subtracting 3 does nothing. So you can basically just ignore that -3. It's not important in the long run. So my initial gut reaction for what I should compare it to didn't help, but I was able to compare it to something else that I know converges. This was less than that, so he also converges.
Wait, where'd you get the 1/3n?
I just made it up. I guessed, I picked, what I was trying to do is I was trying to find something that I know for sure converges or diverges, that I was for sure bigger or smaller than this. And I didn't guess 1/3 to the n the first time. I tried 1/4 to the n. But since that didn't tell me anything, I couldn't compare those because they weren't, it wasn't smaller than something that converges. That didn't help. So I had to change what I was comparing it to. So I just picked something else. It could be anything. I mean, you could have picked 2 to the n. 2 to the n also converges. This is smaller than that, so this also converges.
So you just like pick it now.
You can pick, yes. There's no thing saying it has to be 1/3 to the n. It could be anything you want, as long as you know it converges or diverges, and as long as you are sure it's bigger than that, so you could say it also converges. So, like I said over here, this and guessing what to compare it to can be tricky sometimes. Always go with what you think it is first, but then if it didn't help, then you might have to make an adjustment like that. Okay, look at question 3. What do you think? So, to know what to compare it to, some of it is that it takes a little bit of experience. Some of it is that it's just hard sometimes. But you can also kind of look at this and you can start to kind of figure out what the important parts are. You want to focus on the important stuff. Is this +4 going to be that important? Not really. Even the times 7 here. Like, if this converges or diverges, multiplying the denominator by 7 is just going to make it converge or diverge quicker. So really that doesn't even matter either. The stuff that's really important is the 1 over n squared. So to me, that's what I would try to compare it to. And since this is I'm not going to count off on your homework if you don't do this, but I would highly recommend that you make yourself write these things out. This is a p-series where p is 2. Since 2 is bigger than 1, it converges. If you make yourself write that every single time, you're going to get really good at those. I identified the type, what mattered, because of that, it converged. And again, that would be helpful for FRQ also. Okay, but this is only good if this is bigger than the original one. Because if this is smaller, that means this is bigger, and so what? This might converge to 20, but if that's bigger, I can't guarantee that it's going to converge to 21 or 22. It's bigger. It could go to infinity. So when we compare these two, does adding 4 to the denominator, and makes your denominator bigger, if your denominator gets bigger, does your fraction get bigger or smaller? Okay, so that's good for this. If you multiply something in your denominator by 7, does that make your denominator bigger or smaller? Bigger, which makes your fraction smaller. So both the plus 4 and the times 7 makes this side smaller than this. So if this guy converges and this guy's less than that, this guy also converges. Okay, so there's a lot less examples of these, but this is something that you can now do for now, forever. If something's not geometric, but it's almost geometric, it's like geometric minus a 3 or plus a 3, or plus a 3 or minus a 3. Try to compare it to something geometric, and if the thing you're comparing it to converges, make sure that the question is less than that so you can say it converges as well. Or pick something to compare it to that diverges. Just make sure that the thing that you picked, the question you're answering is bigger than the thing you compared it to if it diverges. That way you're sure that it also goes to infinity. Now these are the only 3 examples of these that they have. So any of this you want to talk about again for that type of comparison test? I feel like this one should be a little more intuitive. So, okay, the other one, now again, completely separate. This is something different. The limit comparison test is a little bit more of a process, which is nice. So as long as the question, the series is being asked, as long as it's positive, and the thing you're going to compare it to is positive, if you were to divide those, the sequence or the series of the question divided by the series of the thing you're comparing it to, if you take the limit as n goes to infinity of that, if you get a number that is finite and positive, then both of these, they either both converge or both diverge. So kind of the same idea where we're going to have to guess something compared to. That's going to be b sub n. And we're going to take their a sub n, divide by our b sub n, take the limit of that, and if the result is any finite positive number, then whatever we compared it to, if our b of n converges, then the original question converges. If our b of n diverges, then the original question diverges. So there's a lot of practice of this because this one, again, is not as intuitive, and it's also kind of hard to see what to compare it to. So kind of like what I was saying a few questions ago, the to know what to compare it to is definitely the hardest and going to be the most uncomfortable part for a while. But what you need to try to think of is you need to try to focus in and think of the most important stuff. The -2 is not that important. The +1's not that important. even multiplying something by 3 is not that important. The most important stuff is right here. Now, if I think of this reduced, if I think of n squared over n to the 5th reduced, that's like 1 over n to the 3rd. This is what I'm going to compare it to. This is what I'm calling b sub n. All of this is a sub n. So I'm picking a b sub n that I know the answer to. If I make b sub n be something I don't know if it converges or diverges, this doesn't help you. But I picked a b sub n where it's a p series, p is 3, 3 is bigger than 1, so it converges. So what I want to do with the limit comparison test is I want to take the limit as n goes to infinity of a sub n, so that's the one they gave me, divided by b sub n, the one that I'm guessing. Now, dividing by this is the same as multiplying by the reciprocal. And now try to imagine this being reduced. This n to the 3rd reduces this n to the 5th and leaves an n squared. This is why I picked this, by the way. And again, that's really hard for you to see right now. But I picked the thing so that if it was here, it would reduce this and make these be the same. Now that this is degree 2 and this is degree 2, I see this limit is 2/5. Is 2/5 positive?
Yeah.
Is it finite?
Yeah.
Then it has the same answer as this. So if that guy converged, that guy converges also, because they do the same thing. So if I had picked something to compare it to that diverged and this happened, the answer would be diverges. It would do the same thing as what I compared it to. All right, so again, trying to guess what you want to compare it to is just very difficult. But you can kind of see you want this to cancel and reduce this so that these degrees are the same, and then you can find that limit reasonably easy. So let's have somebody take a guess on what you think we should compare it to in question 5, besides Lana, because she's a bad guesser. But
1 over n squared.
okay, 1 over. Did she say something?
I said, oh geez.
Okay. Why'd you pick 1 over n squared?
Because like 5 and 5 don't really matter. 5 in front of it doesn't matter anymore.
Right. That stuff's not as important as the rest. Also, he picked out something. Why is this a good try? I don't know that this is going to work. How would I know that this was a bad try or a bad comparison?
Because if you multiply the reciprocal, things go away.
I'm sorry?
Because if you multiply the reciprocal, things go away.
Okay, that's true, but I was looking for something else. Do we know if this converges or diverges? Yeah, well, you have to pick something to compare it to that you know the answer to, because this is going to do the same thing as this if that limit is positive and finite. So why do all that work to still just have a question mark? This is a p series. P is 2, 2 is greater than 1, so it converges. So now we can try to do not the comparison test, this is the second one, the limit comparison test. The limit comparison test is going to have a limit in it. You're going to take a sub n, which is the one given to you, divide it by b sub n, which you are hoping is a good comparison. Dividing by b sub n is the same as multiplying by the reciprocal. Over time, you're going to get better at guessing the thing to compare it to, because you really want this to reduce this. Or actually, you don't even necessarily really even need to reduce these. This makes the numerator 1n squared. This makes the denominator 5n squared. Again, when you're talking about really big numbers, this doesn't make a big difference. So what does that limit come out to be then? Okay, and since 1/5 is a positive finite number, the answer to this question is the same as the answer to that question. This converged, therefore that converges. I don't care what the limit goes to, just that it's positive and finite. Okay, so Will gave us a good guess for that one. I would like somebody, and again, it's perfectly fine to guess wrong. There's nothing wrong with that, but I need y'all to sometimes see why some of these are poor guesses. So in question 6, what do you think might be a good thing to compare to in this? 1 over the square root of n is also what I would pick. Again, sometimes you just don't know. This is also a good pick because I know if it converges or diverges. It's a p-series, p is a half is less than 1, so it diverges. So if I do this limit thing and I get a positive finite number, then I know this diverges too. That's where that would be helpful. It's going to do the same thing as the thing I compared it to. So this, again, this is like the square root of 3 times n to the 1/2, and then the plus 2 just really doesn't make much of a difference. If I multiply this by the reciprocal, dividing by 1 over n to the 1/2 is the same as multiplying by n to the 1/2. You can see that these are going to cancel, and again, depending on whether you ignored this or not, I don't know. Either way, you're going to get, I would say mine was this. Doesn't really matter what the number is. If it's positive and finite, you guys know what finite means? Yeah, not infinite. Something that you could count to, I guess, if you had enough time. If you had unlimited time, could you count to that number? By the way, there's whole classes called finite math after college algebra usually. Anybody doing finite or take finite last year? You are?
I took it sophomore year.
You took it sophomore year?
Yeah.
Well, I didn't know they'd let you take it that early. It's been a long time since I did finite math, but I remember like probability, Venn diagrams. Did y'all do probability?
A little bit. There was a lot of like equations that relate to like economics and like compounding interest and stuff.
Oh, linear programming maybe? Does that sound familiar?
Yes, that sounds familiar.
Okay. Anyway, so that limit was a positive finite number, so the answer to this is the same as the answer of what I compared it to. This diverged, this happened, so this diverges also. Okay, somebody else. Again, I'm trying to get some wrong answers, partly so I can maybe try to show you why that wouldn't work out great. But what do you guys want to guess for number 7?
1 over n squared.
1 over n squared is also what I picked. This is a p-series where p is 2, which is greater than 1, so this converges. Again, this is not a good comparison if you don't know if it converges or diverges. By the way, this is why I was lecturing you guys so much on being very comfortable with p-series and geometric series and stuff, because we're just using it to death here. Okay, so limit as n goes to infinity of a sub n divided by b sub n, or multiplying by the reciprocal of b sub n. And again, that's a great pick, not just because I know whether it converges or diverges, but this n squared, you can think of it as reducing this from n to the 5th to n to the 3rd. And just like infinite limits and horizontal asymptotes, the only thing that matters is this first part. So the limit's a half. I could care less that it's a half. I care that it's a positive finite number. And because that's true, what I compared it to is also the answer to the question that I started with. So the limit, I mean, you got to do limits, I guess, but you're pretty much trying to always do limits where you've got the same degree on the numerator and denominator, so that's pretty consistent. By far, though, the hardest part is trying to guesstimate, and y'all are doing a great job, but that's still tough to see that 1 over n squared is a good choice. Sometimes that doesn't even work. Give me, actually, very next question. When I tried to redo this one the other day, I did not pick out a great comparison. It didn't help me. So I had to just almost just start over and pick something completely different. But that is part of the learning process. So what would you try for number 8? You're probably not going to pick the right thing, so it doesn't really matter.
Over n squared.
Okay, 1 over n squared. And are you thinking because when you flip this and cancel this, then the ends match up?
Maybe, yeah.
Okay, so I think that is a very reasonable guess. We know this converges or diverges? Converges. Rebecca, you had this. So if I do this divided by this, and then try to do the limit. Sure, this could reduce this down to an n. Now you've got an n to the first over an n to the first, but what about this 3 to the n? That's not insignificant. That's not like just adding 2 each time. That's adding 3, then 9, then 37. This is going to grow extremely big. No, well, maybe, but we don't have to go that route. What I did is I said, okay, let me pick something else here. Instead of just doing this, I also would really like this 3 to the n to be canceled out. So instead of doing 1 over n squared as a comparison, because I couldn't do that, that limit wasn't finite, so the limit comparison test was not working, I can change this. Now, we haven't really talked about this much, but this is a good thing that you need to be thinking about. This is not a geometric, this is not a p-series, this is not any of those. You should still know whether this converges or diverges. Because which one of these two is going to grow faster? The top. So if your numerator grows faster than your denominator, then your fraction heads to infinity, which means this diverges. So now that I have this comparison that I know diverges, those can cancel. Now the limit gives me 1/4, which is a positive finite number. Therefore, the answer to my convergence of b sub n is the same as the convergence of the original question. So, myself included, I did not try 3 to the n over n squared. I mean, it was possible that I could have guessed that, but I also tried 1 over n squared, saw that 3 to the n was still a problem, so I figured to get rid of the 3 to the n, I'd love to divide by 3 to the n, so I just put a 3 to the n here. But it did change to this from converge to diverge, which changes this from converge to diverge. I'm not saying this is the only thing to compare to either, by the way. You can pick any comparison that you want. It's just that most of the time there's something that's going to be a little bit easier. Okay, we got one more of these, and then I'll have you guys try some. And honestly, a lot of these questions are multiple choice, and they're kind of conceptual questions. So not so much like what I'm doing here. A little bit, but not as much. Okay, so b sub n, what would be a good guess for b sub n? N to the 1/2. Trying to think. I don't think I'd do n to the 1/2, but what if we did, I'm trying to think of this reduced. This reduced helps you here. So 1 minus 3/2 is negative 1/2. So let's try not into the 1/2, but 1 over into the 1/2. This is a decent pick because I know it's a p-series that diverges. P is a half, which is less than 1. That's how I know it diverges. Then I can try to figure out this limit. And again, I'm only really worried about the biggest stuff. So I've got an n over like a n to the 3/2. I don't know, plus the square root of n. But the plus the square root of n doesn't matter. This grows much faster. Okay, if I try to divide by this, it's the same as multiplying by that. Now, this is n to the 3/2, 1 n to the 3/2. Down here, this is 1 n to the 3/2, plus some other stuff. So the limit as n goes to infinity, since the degrees are equal, leading coefficient over leading coefficient, and 1 is a positive number, it's also a finite number, therefore the limit comparison test works, which means the answer to this infinite series is the same as the limit as this infinite series. Diverges. So again, before you practice a couple of these, keep in mind there's 2 things that you can do. I think the easiest is the first thing we talked about, but it's got to be very close to something we know how to do. It's got to be fairly simple. Question 1 was basically geometric, but we added 3 to the denominator. Question 2 was basically geometric, but we subtracted 3 from the denominator. Question 4 was basically a p-series, it just times 7 and a plus 4. So we had things to compare those to, and if it was less than something converged, then it converged. If it was bigger than something that diverged, it diverged. And if it didn't do either of those, we had to keep exploring. But on the messier questions, like, I don't know a good direct comparison to this. I can't just say, I will compare this to 1 over into the 3rd, which I know converges. Because I don't know how this, if this is bigger or smaller than this, I don't know. I'm not confident in saying which one's going to be bigger or smaller. So when you are not confident which one's going to be bigger or smaller, that's when you want to do the limit comparison test. Try to think of something that if you multiply it by its reciprocal, it would reduce and give you an easy infinite limit where the degrees are equal, and then the answer should be the same. Okay, I would like you to look ahead to the next page, and I think the first set we should probably talk about is the first 3. So I want to give you some time to start those and see what you come up with. So I will not expect you to have this finished when you come to class next time, but we still got about 12 minutes, so I want to get through a few of these questions today, and I will ask that you do just a couple more for homework, but we will finish it up together next week, or not next week, Friday. Friday is an A day. discuss those three at least. Okay, so in this question number 1, without even going through the entire question, 2 of these should not even make any sense at all, but doing almost no effort. Why should choice A get really no consideration?
Harmonic series.
Right, this is the harmonic series, and what about the harmonic series?
They diverge.
Yeah, so there's no way that a comparison test is going to help you figure out that it converges to anything. It diverges, so it could be that it tells you that this diverged, so D is a possibility. And then these two are the same. These are P series where P is greater than 1, so do these converge or diverge? Okay, so then which one of these two doesn't make sense? See, so if nothing else, just knowing this diverges and these converge, understanding that what you compare it to has to do the same thing gets you already down to a 50-50. Okay, the next thing that I would do is I would try to compare these. So if I thought I knew how this compared to this, if I was confident that this was less than this, I could say B. I'm not sure if this is less than this. Or if this is bigger than this, I can confidently say this diverges. Because if this goes to infinity, if it ends up being bigger, then it definitely goes to infinity too. So 1 over n, 1 over the natural log of n plus 2, which one of these grows faster? Well, natural log looks like this. It grows, but it grows very slowly. So wait, how does that help me? I would need it to be bigger to help me with that. Huh. Okay, well, I'm definitely overlooking something there. That shouldn't be that difficult because I just flew through this earlier. But D is what the correct answer is. But I'll have to come back and think about a better way to explain how I knew this was bigger than that, because that doesn't seem intuitive to me now that I think about it again. Oh, yeah, Mick.
I just like compared like ln n plus 2 to n, which is like kind of like, well, I just like compared like ln n plus 2 to n, kind of like with the table, and basically like it gets like, if you plug in a number to ln of n plus 2, it like, as the numbers get bigger, you like n, or the number you get out of that's gonna be smaller than what you get in. So like ln n plus 2 has to be like less than n.
Thank you.
1 over n would be like.
Yeah, so what I was thinking is I was trying to compare n to this, and I shouldn't be doing that. I wasn't thinking about these being the denominator. So the bigger your denominator is, the smaller your fraction is. So n is bigger than this, which means this is small, the fraction smaller. The smaller your denominator is, the bigger your fraction is. And so if this guy's going to infinity, this guy's definitely going to infinity also. Thank you for that quick reminder. Okay, question 2, which of the following series converge? Well, this one you kind of had to do quite a bit of work here. You had to think about each of these. I guess we can go over these next time, but what did y'all think the answer was in number 2? I can at least give you a thumbs up or a thumbs down. A is correct. So, on Friday we'll talk about why the others don't work. And then in number 3, I'm guessing that you compared this to what? Okay, which is geometric, and he converges. And then this has to be smaller because it has a
Larger denominator.
exactly. So if this is smaller than something that converges, then he also converges. So, okay, again, I'm always happy if you do more, but please do a couple more of these outside of class so your brain has to think about them again. Even if it's just 3 or 4 questions, that's fine. We will work on them some more together next time and try to iron out all the issues there. I probably will do some kind of corrections or something for today's quiz, not because I haven't even graded most of them. But all of those questions are AP level questions, so I feel like it deserves a little bit of the curve. Is a little bit. The question types are a little harder than some of the others. So, but we'll figure that out once everyone's taken it and all that kind of stuff. So.
The P-period question on the test, was that numbered? What was the question? It's like, which just, well, yeah, I know. When is it? But I just wanted to say this. It was like, one over n. 1 over n sub
All right. If you still have one of my calculators out, please bring it back.
It was like one of them was square root and that's what I wanted. One of them was geometric. Maybe 2 of them. But then one of them was square root of 8. Hopefully that's
Have a good day. Goodbye.
I did.
So then it's going to be a negative. So I did negative something minus a negative something plus minus plus something.
Yeah, that's what I was saying.
Yeah, I just thought of that.
Oh, you mean the 1 over t squared plus t squared?